Okay, so we've learned how to write our code, we've learned how to design our code. Now we need to make sure that our code is readable and presentable. Now, this lesson is actually going to be applied to both the grade 10s and the grade 11s. And the main reason is it's basically the same no matter what language you work in. So why not kill two birds with one stone here? So basically what we're getting at is the fact that there are certain standards of practice out in the professional world that most businesses follow. And the reason why they follow these things is it makes it easy for new employees to join their company. It makes it very easy for groups to work together, so multiple people on a team. So the idea is that everybody's code looks relatively similar. It's well documented. By that we mean that it's easy to read in terms of the code itself, but there's actually support documentation, support writing in the code itself to try and describe and explain complicated pieces and chunks and large blocks of code and whatnot. And that is a super important aspect of programming, one that you don't truly appreciate until you walk into an environment that doesn't have that. And it can be a very painful process. I can recall walking into one company that's going to remain unnamed at this point that handed me 1,000,000 lines of code written in C. And if you've ever seen C, it's a sight to behold, that had no support documentation whatsoever. And it took forever to achieve anything because you had to go through and analyze so much just to figure out what was going on. It was not an effective way to actually work. And it wasn't entirely the company's fault. It was the fact that the code itself was over 20 years old and hadn't been updated, hadn't been replaced. And in fact, the original programmer was actually still working on it. And obviously, people don't like to change. That's what it breaks down to. But anyways, so we're going to adopt these standards of practice that you will find in almost every company you work in. Now, most companies will use this and then slightly vary off of it a bit here or there to suit their needs. But they're all going to follow the same basic foundation and structure. So let me just read this over. There's no PowerPoint today. It's just this one document. And then I'm going to give you a demonstration, and that'll be it. So in the business world, programmers will often work in teams or have to demonstrate their code to their supervisors, who will often not have any programming knowledge at all. So the question is, how do we make our code understandable to everyone, even the untrained? And that's the definition of code, is that not everybody is supposed to understand it. So somehow we have to make sure that it is. The simple answer to that is readability. Readability is basically how easy is your code to understand at a glance. And I mean a short glance. Can I look at your code and figure out what's going on immediately? Or do I have to sit there and stare at that one line of code for 30 seconds, a minute to figure out what you're doing? If I do, that's not a good thing. But it's not the code's fault. Sometimes there's just complex code and it needs to be like that. So we need other ways. So what we do is we structure and we space and we document our programs to make sure things are what we expect them to be. So as it says, our goal is to make our programs as easily readable at a glance as possible. This means well structured and well explained. So we're going to go through a number of different sections here, as you can see: structure, white space, documentation, and the header. Now, piece by piece here. First of all, structure. It's important to structure our code in a sensible manner. This means grouping together similar or sequential code. For example, getting input from a user, it makes sense to group that together, group together the two commands, like the prompt and then the request, the prompt the user and then getting the information request. We call these groups of similar or sequential code blocks. So you might hear me say, you got to document your code block. Each code block in your program needs at least one comment, things like that. Now, a code block can be a single line because it's all on its own. There's nothing around it that's related. Sometimes it might be 5, 6, or 10 lines of code. It depends, but it probably won't be too much more than that because oftentimes bigger code blocks then get broken down into smaller code blocks within it. So for example, I might have a code block that represents all of my input variables. But not all of those input variables are related. Yes, they are all input variables, but they're not related to their own purpose. So I might have one set of input variables that represents the dimensions of a shape. I might have another input variable that represents the cost of something. Just because they're input variables does not make them related. So I would keep the dimensions of that shape together because those are related, but then I would separate that and keep the cost separated from that original chunk. And that happens in all of our code. As our logic breaks down, we look at our lines of code, our logic, and we say, well, these 2 lines are next to each other, but are they related? These 5 lines are next to each other, but are they related? Do they have the same goal? That is your intent. So you're going to group your code into code blocks based on goal. What is the goal of that block of code? If it has more than one goal, separate it. If they're all working towards the same end, keep them together. That's your goal. So that's really where the structure and the white space come into play. So white space, this is exactly what it sounds like. This is the white space you see in your code that helps logically break apart the program into smaller code blocks. Now I'm going to show you something and you'll be like, oh dear goodness. Here we see 2 programs. On the left we see a Java program, on the right we see a C# program. They are both the exact same program. Now what you'll notice is that everything is just chunked together. I have purposely got rid of all formatting. So everything is shoved to the left, everything is squished down, there's no space between anything whatsoever. We're going to fix these up, and that's going to be our goal for this whole lesson. But what I want you to see here is what it looks like when we don't clean up our code. This is unreadable. I wouldn't, if somebody handed this to me, I'd be taking marks off all over the place. If you handed an essay to your teacher, imagine you're writing an essay for your English class, and you handed it in, and you had your introduction, you had your 3 bodies, and you had your conclusion. But you didn't actually break them up into paragraphs. You just handed them a big wall of text. You're not going to do too well on that. Your teacher's going to rip that apart. Why? Because they can't read it. Imagine going to a website, some news article website, you're reading about your favorite video game, your favorite cars, whatever it is you're into, and instead of them breaking apart into sections with subheadings or paragraphs to break apart the ideas, they just give you a wall of text. What's the first thing you do? You click away. You're like, I'm not reading that. There's not a chance I'm going to go through that. Where's the tilde? Where's the TLDR? I'm not reading any of this. So our code is basically the same idea and the same thing. We want to break it apart by ideas, by goal. And that is what our code blocks are. So we're going to do that with this code today in a minute. Oops. All right. So let's actually start out with that. So let me just finish reading that white space paragraph so you understand everything. So this is exactly what it sounds like. The white space you see in code that helps to logically break apart the program into smaller blocks of code. For example, a code block to calculate the area of a rectangle could be made up of many blocks within the overall block. Blocks such as creating variables, retrieving data from the user, calculations, and output. But those blocks may and should have further grouping by specific purpose. So, as I said before, you may have a block of code that represents getting all your input from a user. But is all that input related? So you might have 4 lines of code that represent getting the user's name and their age. But then you might have another separate chunk that's all about getting unrelated information that has nothing to do with the person's personal information. So you would separate that chunk. You'd separate those blocks. That'd be the idea. So let's go over to our other programs that we were just looking at a second ago and break them apart by purpose. So first thing is first, let's look at our indentation. Our indentation is completely broken. Okay, so we're going to do it on both sides. The Java on the left, C# on the right. And I know the difference because I can see what the code is. We see our system.out lines on the Java, and on the right, we see our console.write line. Now, how do we know what to indent? Remember, opening and closing brackets, anything inside of opening and closing brackets like that needs to be indented. So I'm just going to select that whole chunk and hit Tab. So I've fixed that. Now I got another set of opening and closing brackets. So I'm going to select this whole chunk and I'm going to hit Tab. Immediately my program starts to become more readable just because I can see where things belong. I got an extra space there I shouldn't have. So we're going to do the same thing over here. So we're going to grab everything inside the opening and closing bracket and we're going to bring it in. We're going to grab everything inside of this opening and closing bracket. We're going to bring it in. And again, our code immediately starts opening up. Things start to break apart visually so we can see what belongs with what. Okay, let's go in and check it out again. Now, what's the first thing we see in this program is we see the scanner library. It's not related to anything else. It's not related to that class. So we're going to visually break it up by one space. You're never going to have more than one space breaking things up. All right. If you're putting more than that, you're just adding too much white space. And that makes the program just as unreadable again. All right. So it's like if you handed in an essay and you made it triple spaced. The teacher's not going to like that. Right? Typically, they're going to ask you for either single, at most double spaced, because that's readable, it's consumable by the reader. Anything more than that, and it's more work. It's harder for you to break apart things again. So now we're going to look at our variables inside of here, and we're going to break them up. Okay? So again, we have the scanner variable, which has nothing to do with these other things. So it's going to get its own set. Now we look at, we got 3 student marks, we got a sum and an average, and a number of students. Well, that's where our variables end, so we can break that apart. So now we got to look at this. Well, some of these are going to be input variables, some of these are going to be calculation variables, so that's an immediate way we can break things up. Whoa, that's not good. So obviously, those student marks, I'm going to be getting that from the user. So I know I can break that up. It's possible that I might be able to break it up even further. We'll see. Below that, we have our mark sum, which is going to be calculated by adding up all of our marks. Our mark average, which is going to be calculated by adding up all of our marks. And our num students, which is going to be used in the calculation. But it's not being calculated. So I'm going to be separating that. I didn't make this a constant because it just so happens there's 3 students in this version. There could very well be more students if I rewrote this code in another way. So it doesn't really make sense to do that. All right, let's not get ahead of ourselves. Let's go catch the C sharp side up to the same thing. So again, the C sharp side has a library as well. It doesn't have a scanner library. It has a system library. And again, we can break apart our variables from our main chunk there. And we look at our variables. Well, those 3 input variables are related and they're input variables, so we're going to keep them together. Down here, we have the 2 values that we're going to be using for calculation to actually calculate. And we're going to separate that from the other variable that is not being calculated, but is used in the calculations. Okay? So we're separating based on purpose. So these things, their purpose is to store the marks of the students. Okay? These things, their purpose is to calculate the average mark of the students. This thing is to maintain how many students we have in the class. Okay. So we've broken apart our variables. Now we got to go down into the meat of the program, down into the main chunk. Now we look at this and we say, okay, well, I have the first 1, 2, 3, 4, 5, 6 lines of code is all about getting the student marks. Following by that, we're doing our calculations. Following that, we're giving our feedback. Remember, IPSO, input, processing, storage, and output. At the bare minimum, you're going to break apart your program by these 4 categories. Bare minimum. On top of that, you may find that you need to break them apart further within those categories based on purpose. So let's look at the 4 categories first. Let's look at the input section. So input ends right here. So we're going to create a visual break in the code there. Okay. Over here, we can do the same thing. Breaks right there. So far, so good. Now these calculations, we got 2 calculation lines, and we got to think, well, are they related? Do they have the same goal? And yes, they do. This one is calculating the sum, so I can calculate this average in the first place. So these are actually completely related chunks of code, so I don't actually need to break them up any further. And that automatically broke up my final feedback line, our output line, so we got that one for free. We didn't really have to do anything. So immediately looking at this, our program immediately, let me just kind of move this down a little bit. Our program immediately is more consumable. It's very easy to read versus that ugly mess that was there before. All right, so we broke it into its coding equivalent of paragraphs. Now we need to take it the next level, and we need to get into the documentation side of things. So let's go back to our document for a second. Oops, wrong one. There we go. So structure and white space, done. All right. Documentation. Now, I'm going to read this because I need to be precise. This is the act of commenting about a piece of code or project in simple and concise English. means don't be verbose. Don't add fluff. No fluff. We just want you straight and to the point. Okay? You don't have to add any flavor text or anything like that. Just tell me exactly what's going on. That's it. For now, we're going to focus on two types of documentation. There are going to be more later on, but for now, just two. The header and the code block documentation. I already talked about what a code block is. You have no idea what a header is yet, though. The problem is when we actually try to write English in our program, so if we go back to this, for example, and if I just try to write, let's say, for example, I want to write a comment that says, like, retrieve the marks of the 3 students. So something like, retrieve the 3 student marks. If I try and run this program, it's going to crash. And the reason why it's going to crash, if we look at this, it says right here, error expected semicolon. It doesn't know what's going on with this line. It thinks each one of these things is potentially a variable or a keyword, but it can't find it in the dictionary. It can't find it in the Java dictionary, C# for when we get there. So we need some way of telling the compiler to not try and compile this comment. Well, we do that with 2 little special characters. We put 2 forward slashes on there. You see that the line turned green. This tells the compiler to ignore everything on that line after those comments, after those little slashes. I could even technically do it on the same line as a line of code, and it'll ignore that. But at this point in the course, I'm going to ask you not to do any side documentation. I want all of your documentation to go on the line directly above your code block. Which brings me back to the document again, because there's other pieces to this. So the problem is when we try to write in English in our programs, those words are not in the C# or Java dictionaries and will therefore break the program. We won't even be able to compile. So to fix this problem, we're given a new symbol that when used tells the computer to ignore everything on it on that line of code that it's on. The symbol is just a 2 forward slash symbol. You can also use a /* and a */ to get the same effect around multiple lines of code. So going back, I can, let's say for example, this code is broken and I want to just say, I just want you to ignore it for a minute, compiler, while I do other work. So you could surround this entire chunk in a /* followed by a */, and it will tell the compiler to ignore that entire chunk. This is really useful if you're working on one thing and you have another thing that's kind of halfway done, but you don't want it to break what you're trying to do right now. We call that commenting out our code, and because those are the comment symbols. So we're commenting out our code so it doesn't affect our workflow right now. And you can see that it kind of acts like brackets, an opening bracket and a closing bracket. So we have /* and then //. There we go. So that's the way we actually do it. Now, where do we actually do it? So this is what's called code block documentation. So code block documentation means every single code block in our program gets a 1-line comment. So I'm going to put little slashes above everywhere where we would expect to have a comment. So, and we'll fill them in afterwards. So every place, we don't have to comment our main line. That's okay. We've already commented our input. Oops. And then one final one there. So every place you see those slashes, they're always right directly above a code block. And the comment should just tell me what the purpose of that code block is. That's it. Again, no fluff, no flavor. Just what does it do? Nothing more. Okay? Now, if it's a really complex chunk of code, you may have to include like an equation or a formula or something like that. The odd time you might go to 2 lines, but you really should try to avoid that because that reduces the readability. So try and be as short and concise as possible. We don't need to document our libraries. We'll come back to up there in a minute. So for every one of these things, we're going to give it a comment. So in here, we're going to say, set up the input scanner for user input. Great. Here, what is the purpose of these 3 variables? Well, these 3 variables are used to store the 3 student marks. Store the 3 user entered student marks. So not only do I know what they are, I know where that data is coming from. here, store the calculated sum and average student marks. Very short, very concise, but it has everything that we need. Pardon me. And then here, store the total number of students, or just store the number of students, or current number of students. Store the current number of students. Great. I don't need a comment for the main. We come in here. I already have a comment here for the retrieve the 3 student marks, so I don't need that. We know what that does. That's all this whole chunk of code does, is retrieve through student marks. I don't need to specify each little thing. I wouldn't break it apart like that. That is just tedious because they're all related and they do the same thing. So there's no point. What are we doing down here? Well, we're actually calculating this stuff. So calculate the sum and average student mark. Now, this is a very simple formula, a very simple equation of sum divided by quantity. We don't need to include that formula. If it were something more complex, maybe the Pythagorean theorem or something, or the quadratic equation, something like that, then I would think about actually putting in the formula that I'm using. Okay. For very basic things like this, you can ignore it. You don't need to do that. And then finally, we need some comment that discusses giving feedback to the user. So right here we are telling the user what the average student mark is, right? So we have mark average right there. So here we might say something like display final student average. And that's it, display final student average. I don't need any more than that. I know who it's being displayed to. It's being displayed to the user. Otherwise, we wouldn't be displaying it in the first place. And that's it. That's our fully documented our program at this point. Let me shrink this right down so we can see the whole thing at once. You can see it's pretty clean. It's very easy to understand. I don't need to read these 6 lines of code when I can just read this 1-line comment that says retrieve the 3 student marks. Okay, that's it. If I need more detail, then I'll go look in the code itself. All right. Now, the C# side of things, it's no different. So I'll bring that one up just to show it. But basically, we can copy and paste these exact same statements, except some we don't need because the C# doesn't require the scanner, doesn't require the scanner library. It can just do the work. So it's going to start with this one. Yes, we need to store the 3 student marks. Yes, we need to store the calculated sum and average mark. Yes, we need to store the number of students. Nothing's changing here. Down below, yeah, we need to retrieve the marks from the 3 student marks. Yeah, we need to calculate the student marks. You can see how similar Java and C# are. So when you grade 10s eventually take the grade 11, you'll be like, oh yeah, this is easy peasy. What gets more complex is the detail and the depth we get into things, but that's for another time. So now both these programs are in the same state. They're both pretty well documented. We're still missing one more piece to the puzzle, the final piece, the part that's called the header. Now at the very top of your program, this is why it's called a header, because it's at the head of the program, the very top, that's where your head is, tippy top. I mean above your libraries, above everything. The header is kind of like a bit of like a title page for your program. And it gives us all the important information about the author of the program as well as the program itself. So somebody can get a quick glimpse of what's going on within this program. Now the header is made up of 6 pieces. Now I try to get the students to memorize a quick little acronym, rhyming acronym that I've taught over the years. So try and remember this. It's oops, that's not going to work. So just remember this. It's AFPCMD. AFPCMD. Say it to yourself a couple times. AFPCMD. AFPCMD. Remember that, because when it comes time to assignments and tests and exams, you're gonna need to know this, because I'm gonna ask you for this on every submitted assessment from here to the end of the semester. Okay? They're all gonna require that. AFPCMD. So what do they actually mean though? So A is author. F is file name. P is project name. C is creation date. M is modified date, the last time it was modified. And D is description. What is the purpose of this program? So the author, for right now, it's Mr. Lane. File name, this one, as you can see at the very top, Java Prof Practice 1 Demo. Actually, sorry, no. Main.java is the file name. Over here on the other side, I'm going to copy and paste this. Over here on the other side, this is going to be main.cs. We see it right there, main.cs. Project name, over here we have Java Prof Practice 1 Demo. Okay. A little long-winded, but okay. And over on the other side, it's just Prof Practice 1 Demo. You can tell which one I made first. I'm not allowed to have duplicate names. Oh my goodness. Creation date, well, I'm creating this on October 6th. So October 6th, 2020. And it's the same thing over here. And the modified date, well, it's the same day. Now, why would we normally have this? Because if you're building like larger programs, that modified date is going to be the last time somebody poked their head in there and started changing things around. So if you're on a team, this is pretty useful. It's useful for finding things like if somebody broke something, when the last change was made, so then you can start to track down who made the change and what change they made, things like that. And the description, now, for now, what the description means is what is the purpose of this program? What is its goal? Later on, when we start to have multiple files, it's what is the purpose of this file? But for both grade 10 and the grade 11, these are single file projects that we're going to be doing for the entire semester. So, what is the purpose of this program? Well, this program calculates the average of 3 user-entered student marks. That's all it does. Calculate the average of 3 user-entered student marks. Short, concise, tells me exactly what I need, no more, no less. And that's it. We are now officially done. Fully documented, fully styled program and using all of our professional practice guidelines and everything. You can see immediately that the code is much more consumable from its original state. You can see how things are broken up. The green is actually a nice color that helps you really tell the difference between everything. Now, if I put this in light mode, please don't go blind for a second here, but I'm going to put it in light mode so you can see the difference. Whew, okay. Not exactly pretty, but you can still, things are still broken up. Okay? I'm going back to dark mode. I can't handle this. There we go. That's better. All right, so let's go back to our document real quick. So we covered the documentation, the header, and we even talked about this idea of code block documentation. Now you see these 2 tables at the bottom here. Those 2 programs that we just edited, I'm going to copy and paste them in here so you can see the full version of things when you come and look at this document, what the final product should actually look like, so that when you go to do the same thing for your programming assignments and whatnot, you will have something to model yourself after. And that is professional practice number 1. And I say number 1 because later on, we're going to start adding to this. Just little bits here and there, though, not huge chunks. Today was the foundation. You're not going to have to learn much more after this point. Okay, good luck and happy programming.